I'm Joost Wagenaar. I'm an assistant professor at the University of Pennsylvania, and I run a lab on using technology to accelerate scientific research and foster collaborative research. So in my lab, we're working on how to use technology to foster collaborative research, and doing that through kind of developing software platforms at scale for the neuroscience community as well as the immunology community and other efforts at the NIH. I started this effort about 15 years ago by thinking about what could we do if we had all of the data at our fingertips and all we had to do as scientific researchers is asking the right questions. I'm strongly convinced that the biggest bottleneck to accelerating scientific research and clinical impact is the lack of infrastructure to bring together data, knowledge, and domain expertise in a meaningful, secure, and scalable way. The good news is that we know how to solve this. This is not a scientific problem, this is an engineering problem that has been solved in industry for many different years. It is up to us now to bring some of the technologies that are standard in industry to the life sciences and leverage that for our academic progress. So when I think about software as part of scientific research, I often like to think about kind of a parallel effort that happened earlier on with hardware for sciences. I'm doing my research mostly in the neurosciences, and if you look back at the 1970s, every lab was building their own amplifiers, their own electrodes, running their own experiments and their analysis. Then in the 1980s, you saw certain labs starting to focus on developing hardware for use by other labs in their research. In the early 90s, you start seeing some business opportunities where some of these labs turned into companies and individual labs are starting to purchase hardware from these stores. If we look at software, we see the same kind of evolution happening. In the early 2000s, every lab was developing their own software for data acquisition and analysis. About 10 to 15 years ago, you start to see that multiple labs starting to focus on just developing software that could be used by other labs for their experiments. And now in the 2020s, we're starting to see that there are certain business opportunities where some of these software projects come out of the lab and are going to be deployed in industry. I fully expect that over the next 10 years, it is much more normal for experimenters to purchase software to manage their data, to analyze their data at scale. Now that we know that AI is taking over the world, we realize that software becomes an increasingly important role in accelerating science. However, in order for AI to work properly, AI needs to have access to meaningful data, well-curated data, and data that is AI ready. This requires that certain labs focus on the development of these rich data sets, and we're seeing that some labs are specializing in exactly doing just that. The role of repositories in research has always been pretty big. The NIH mandates that data is made publicly available after research is done. However, we're seeing more and more that repositories also play a role on providing AI with the right input for downstream analysis. What we're seeing is that repositories more and more are going to focus not just on archiving the data, but be part of an active day-to-day workflow that researchers are engaged in. In the end, we need to redefine what a data ecosystem for science looks like. It will be an integrated system where multiple repositories work together to integrate data and make this available to AI. As I said before, this is not a scientific problem, this is an engineering problem. We know how to do this, and in order to do this, we require vision, stubbornness, resources, and leadership. I often start presentations by asking the question, what if we had all the data at our fingertips and all we had to do as researchers is asking the right question? Would this allow us to accelerate the development of cures for patients? The answer is absolutely yes. You might ask, why don't we have a solution yet? The answer is that this is a very complex problem. Developing the right data ecosystem requires significant continuous investment from all the different funding sources. Too often we look at individual domains in isolated projects, but we need to really start looking at integrated projects across different domains. In addition, our ability to generate large-scale data has grown significantly over the last couple of years, while our ability to analyze that data has not kept pace. This is why I strongly believe that we need to focus on developing infrastructure, developing the technologies bringing the technologies from industry to academia to help solve these needs. If we do that, I believe we'll see a significant acceleration in our pace of research and how we can drive impact for clinical research. So what we're seeing is that we need to look at science more and more as a team sport. It's no longer a single lab that is doing everything from data generation, analysis to publication. Instead, we need to work as teams where there are data generators, data curators, people with analysis capabilities, and then people who can look at that data in context of a much larger scientific effort. The complexity of the problems that we're trying to solve is significantly larger than they were 20 years ago. And it requires a team of domain experts that can bring all different pieces of the pie together. Another important aspect is that we need to build solutions that are targeting specific different use cases. Whether we develop products for clinicians or data scientists or our students, they're all different use cases that want to interact with the data in a different way. What we're seeing is that by building custom solutions for these different use groups, we can actually have them leverage these tools in a better way. For example, if we're building tools for clinicians and we want them to use the latest AI tools, it's very important for them to have a user interface that they can interact with because they're not technically savvy. And so figuring out how to make these tools available to clinicians in a meaningful way is very important. Similarly, when we're making these tools available for students, we need to take a very different approach in how to make these tools available. I think that by including technology and software engineering as a vital component of research, we are able to accelerate our output significantly. Things that we dreamt of 10 years ago are now technologically feasible. Like the data that we were only dreaming of 10 years ago again, now we can actually generate that. I strongly think that over the next 5 or 10 years, we'll see a big shift in how people interact with software developers, and that see a lot more software developers have prominent roles in scientific research. Our team now not only comprises data scientists and researchers, it also now includes software engineers, user experience domain experts, user interface people, and front-end engineers. We don't yet know exactly how AI is going to change scientific efforts and clinical impact, but we do know that things are changing rapidly. If we're interested in bringing AI to the clinic, in bringing AI to patients, we need to do that in a meaningful way, in a scalable way, in a way that we can trust, as well as embrace all of the security requirements around that. I'm very optimistic of where these things are going, both from an AI point of view, but also from kind of a data ecosystem point of view, where we're working more closely together with our partners within Penn and beyond Penn on leveraging the data in new ways that were previously not possible. Science is a puzzle that we'll never complete. There's always more to find out. I do think, however, that it will be easier to fit the puzzle pieces in the right space by embracing software, by embracing AI going forward. It's a fun endeavor. It's going to be very impactful for not only for scientists, but also for clinicians and ultimately patients to figure out how to best explore the knowledge that we have, how to integrate our domain expertise across different fields in the sciences. Comparing this to 10, 15 years ago, the pace at which we can make progress is significantly larger, which is exciting and makes me very optimistic about the future.